Hey guys, welcome back. This is the third installment of our Material World Conversations, and today we're going to talk about what the atom is made out of, because obviously we have a material version of the atom, but what the heck is it made out of? Now, we propose that the atom can't be made out of magic, can't be made out of mathematical equations. It must be made out of some sort of material. And so when we talk about the units that make up this material...
So hold on a second. Let's take a step back. The
Oh,
material
please.
has to have units because it has to bend. And you can't bend something if it's not made out of subunits.
Yeah, exactly. So when we talk about this material, exactly, it has to be some sort of composite material, right? We know that the atom is expanding and contracting. You know that atoms move around, and if you're beginning to become familiar with our radioatomic model, this elastic atom, we know that it's got to flex and bend. And anything that flexes and bends has to have pieces to articulate it.
And this is in opposition to another philosophical perspective proposed for a material basis of the universe, which is the fact that everything is made out of a single object. And this monist worldview is popular in some circles, but it doesn't end up working out because of this physics of bending.
Yeah, it gets even more complicated too, because, our model of the atom has essentially a medium that separates the shells of atoms, right? But we're saying this medium has structure, and the structure we can learn about through the behavior of light and gravity. And we give it this filamentary structure, which we feel like best represents these phenomena. But this introduces a new problem, which is that the filaments have to transect one another as these atoms move around, right?
And the reason they have to transect is because you don't just get snarled helplessly in the web of atoms that you're moving through. It's not like it's not like you're a fly getting caught in a spider's web when you try to walk through a room, despite the fact that the atoms on either side of the room are connected to one another. You're free to pass through, not really affecting anything as you do it. And in order for that to be the case, the filaments have to be able to break and then reanneal after you pass through them with absolutely no detectable force on the macro scale.
And the evidence keeps piling up, In order for any of our basic phenomena to make sense, light has to be seen as a relay event between atoms that are right next to each other, and gravity too. As bodies move around the solar system, these giant bodies, they're constantly having to form and break connections with one another, which we use to explain the inverse square law in our gravity video, which you can check out on the main page. So we know that the medium which connects the atoms together also has to be able to form new connections and lose the old connections. And so the only thing that we can reason which is capable of that is some sort of a fibrous material that has the ability to clasp and unclasp with itself. And so we don't really understand the particularities of that. We spend a lot of time thinking about it, and you should definitely come kick it on our Discord page and try to make sense of this. There's been some really interesting proposals. But what's important for today is that the idea of a fiber is unique in opposition to maybe what you're used to in fundamental physics, where you hear about particles. Because as much as a particle sounds like something which is material, it turns out that particles are actually just points where some quantity is in flux. They're really just locations where a measurement is either predicted or taken. And so we've really eschewed this idea of particles in favor of something that can be thought of as an actual material, something with a surface, with architecture that enables it to undergo all of these interactions, which eventually are going to allow us to explain this uncoupling and the transit of filaments past one another and the interaction of atoms during gravity, where they're actually able to make new connections with new atoms.
And I'd add also that by you can translate between a lot of the conventional quantum terminology into material world terminology in a pretty straightforward way. So particle, if you take it to be a measurement of something that's happening, would be a place where the fiber has has structured itself into something that is detectable, right?
Something it's doing. It's an activity being done, right?
It's like a resonant node. It's like we talk a lot about things being resonant. I don't want to get too woo about this, but you can imagine that everything on the atomic level is vibrating, and the way that the atoms vibrate affects the nature of the fiber in between them. And so if you have the kind of Chladni plate resonance of an entire system vibrating at once, you're going to have places where you have little nodes of activity, and that would be detectable, because even though you can't really detect a single filament, obviously if the atoms are made of fiber, then you can detect when you have a bundle of the fibers and they've formed some kind of structure.
And then I guess one final point that I'd want to make is that oftentimes when you hear classical ether theories, the ether is treated like a fluid. And we don't think this is the right approach because of the fact that all evidence points to the idea that if there is a medium in the space-time sense, it carries a tremendous amount of tension on it. And gravity itself seems to indicate that the material is capable of loading tension. And so while, of course, there is some fluid surface tensions and things like this, in terms of an actual rarefied medium, it only really makes sense to have some sort of interlocking fibrous structures that can pull that off. And so while we do imagine that there's a lot of fiber in between atoms, we imagine that it must be woven, it must be annealed into structures that are capable of bearing that tension. And this is ultimately how we end up with this filamentous model.
And if you are particularly mathematical and you want to help us figure out what the math and the geometry of something like this might be, like Shiloh said, join us in the Discord, because that's an active line of investigation that is not anywhere near done.
So let's stop here for today. Next time, maybe we'll play with polarization and talk a little bit more about what is really happening during light in terms of the deformation of this medium and the deformation of those filaments, so that we can start to poke at ideas like diffraction and eventually get to the double slit experiment and some of the spookier stuff which needs addressed.
See you next time.